9a. In the diagram, BC is a vertical wall standing on a horizontal ground AB. D is the point on AB where AD equals 58 meters. The angle of elevation of C from A is 26 degrees. The angle of elevation of C from D is 72 degrees. 1. Show that AC equals 76.7 meters correct to 1 decimal place. Okay, first let's put in the information the question gave us. So that's angle of elevation of C from A is 26. So this means that this angle over here is 26 degrees. Then angle of elevation of C from D is 72 degrees. So that's this angle over here equals 72 degrees. And we want to prove that AC is equal to 76.7 meters. So basically find AC and make sure that the answer is 76.7 to 1 decimal place. So we have a right angle triangle in the diagram. This means that we might be able to use trigonometry. But then if we were going to use trigonometry, we would need either side length AB or side length CB. And right now we cannot find AB or CB. We can also look at the triangle ADC, which is not a right angle triangle. So this means that we can use the sine rule or the cosine rule. To use the cosine rule, we would need AD, DC, and angle ADC. To use the sine rule, we would need AD, angle ACD, and angle ADC. We already have AD, which is 58 meters. Angle ADC we can find because the angle in a straight line is 180 degrees and ADB is a straight line. So the angle ADC is equal to 180 minus 72 degrees. So that's 108 degrees for angle ADC. There's no way that we can find DC easily right now. But for angle ACD, we can easily find it because the angles inside a triangle always add up to 180 degrees. So this means that angle ACD is equal to 180 minus 26 minus 108, which equals 46 degrees. So we have everything we need to calculate side length AC using the sine rule. So using the sine rule, we have AC over sine ADC equals AD over sine ACD. If we substitute the values for that in, we get AC over sine 108 equals 58 over sine 46. And we can solve for AC by multiplying both sides by sine 108. So AC equals 58 sine 108 over sine 46, which equals 76.683. To 1 decimal place, that would be 76.7. So now we've proven that AC equals 76.7 meters, correct to 1 decimal place. 2. Calculate BD. BD is the side over here. So if we look at the diagram, we have a right angle triangle, and we know that AC is 76.7. And we have an angle inside the right angle triangle other than the right angle, which is 26 degrees. So we should be able to use trigonometry. So AB is the adjacent side, and CB is the opposite side to angle 26 degrees. So we can calculate BD if we actually know the side of AB, because AD plus BD equals AB. So we can find BD by doing AB minus AD. And we already know that AD is 58 meters. So all we need to do is find AB, and we can use trigonometry to do that. So we want to find the adjacent side, and we have the hypotenuse side. So that's cos 26 degrees equals adjacent, which is AB, over AC, which is hypotenuse. So cos 26 degrees equals AB over 76.6. Then we can solve for AB by multiplying by 76.6. So AB equals 76.7, cos 26 degrees. So AB equals 68.92. So if AB equals 68.92, BD will equal 68.92 minus 58 meters, which equals 10.92 meters. And 10.9 to 3 significant figures. B. Triangle EFG has an area of 70 meters squared. The ratio EF to FG is equal to 1 to 2, and the angle EFG is equal to 40 degrees. Calculate EF. If you sketch out what the triangle should look like, it should look something like this. And the angle EFG is equal to 40 degrees, and the ratio EF to FG is 1 to 2. This means that if EF is equal to X, then FG would be double of that. So FG would be equal to 2X. And we are given that the area is 70 meters squared. So we can find the area of a triangle by doing base times height divided by 2, or half AB sine C. In this case, we can't do base times height divided by 2 because we don't have the base and height. The base and the height need to be perpendicular to each other. So we would do half AB sine C to find the area, which should equal 70 meters squared. So if A is X and B is 2X, then angle C is equal to 40 degrees. So we can use that to find the area. So half of X times 2X sine 40 will equal 70. And we can use this to find X because EF is equal to X. Okay, so if I simplify that first, then I can find X by dividing by sine 40. So X squared equals 70 over sine 40. And then I can square root that to find the value of X. And that equals 10.436, so 10.4 to 3 significant figures. 2. A different triangle PQR also has an area of 70 meters squared. PQ to QR is equal to 1 to 2, and PQ equals EF. So we're looking at basically almost the same triangle. If I draw a similar triangle there, PQ is equal to EF. So PQ is basically X. And then the ratio PQ to QR is 1 to 2. This means that the side length QR must be 2X. And both of these triangles have an area of 70. But then it's a different triangle. So the angle PQR will not equal the angle EFG. Basically, it will not equal 40 degrees, but then it has the same area. So this means that half AB sine C for both triangles must be equal to each other because the area is the same. If I fill in half AB sine C from the first triangle EFG, half AB sine C for the first triangle is half X 2X sine 40. And this must equal half X 2X sine angle PQR from the other triangle PQR. And the expression is the same for both of them, right? We have half X and 2X. The only different part would be sine 40 and sine PQR. And if it's equal, sine 40 needs to equal sine PQR, where angle PQR is not equal to 40 degrees. So remember that different angles can give the same sine value, and we can work this out from the sine graph. So if the angle sine 40, so 40 over here, will give a value corresponding to over here. So 40 and sine 40 would be over here. We want another angle that gives the same sine value as 40. So if we draw a straight line across there, it hits the sine graph again over here. And the sine graph is symmetrical around 90 degrees. So this means that that angle, if 40 is 40 from 0, then that angle must be 40 from 180 degrees. So that angle must be 180 minus 40, so that angle is 140. We can even check this. So if you type into the calculator, sine 40 equals 0.6428. And if you type sine 140 into the calculator, you will also get sine 140 equals 0.6428. So it's the same thing. So 140 is the other angle that gives the same sine value, but is not equal to 40 degrees. So therefore, angle PQR must be equal to 140 degrees because it's not equal to 40 and it gives the same sine value as sine 40.